What's up, everyone? So we have here today my guest Eduardo from the Mats, and yeah, he sent me a weird email, and I thought maybe we make a mini podcast on that with some questions. Eduardo, how are you?
Very good, Professor. I don't know, it was really spontaneous. I thought that it was going just to be a regular email conversation.
Yeah, so I think it's maybe interesting for everyone. So and yeah, so what is on your mind?
Well, the main idea is just for me currently, I don't know if I'm changing careers or I'm deepening into a career. And there's a lot of things that I want to explore about data science. And there's also a lot of buzz around it. And I think people says that data science is just statistics in disguise. And and around that, I just wanted to know, like, on your perspective, what do you think is this main subject of interest or the study of data science? Is it bits? Is it we hear a lot of time complexity? Is there any goals of data science itself? Because it's, I don't know, there's a lot of buzz around it, and maybe we lost focus on what's on the core of it.
So I would say data science is sort of an approach to fail as little as possible in finding causal relationships, because it's very difficult to find causal relationships. So it's almost sort of impossible to prove causality in a way, particularly if you have a finite data set, but also otherwise. And yeah, in the past years, as you know, have proven that there are like powerful methods which help assisting that. But still, there's, I think, so for what is important for data science is, so there's knowledge of statistics and knowledge of what is the difference between causality, correlation, and stuff like that. And then there are tools which can be sort of easily used. But if you really want to bring it far, then you have to know how to use the tools best. And for this, yeah, so it's you have to have experience. So it's tough to learn it like by training, I would say. So you have to start doing it. But I recommend, or what we do here at Frankfurt School is obviously we give a firm theoretical understanding, and that helps you sort of sorting out different things and putting different categories in different baskets while learning the stuff. So yeah, that would be my first answer to that.
I think just going through that, it just caught my attention when you said failing as little as possible, because it's also like uh, in the corporate world or in any industries, there's also like this fear of failure, because you have to also, I'm gonna use the word again, these guys, what you're it's not a failure, it's something that we just learned, and always going through the positivity, but also like there's a complexity in failure, because you have to explain exactly what went wrong. And sometimes in data science, or at least coming to this field for the first time, is it just like a black box inside and you just like kind of iterate randomly, or is it we have more control, as you said, like learning what's behind the models, and it's not a black box, it's just complex and difficult to understand. What can you I don't know, say or react on that?
Yeah, I mean that's you raised like obviously excellent points. Yeah, so yeah, black box. So everyone talks about black box, and there's a emerging field, explainable AI, for example. So the black box thing is more or less related to deep learning and to the biggest establishments in the field, where, for example, coming back to what I said, to fail as little as possible, I can also relate this to deep learning or to accuracy or to some scores. Like, yeah, of course, we want to maximize precision, we want to maximize accuracy or other scores. Let's say in a classification, cat or dog, yes or no. And we fail. And yeah, if I say we want to fail as little as possible, you can also interpret that like that. But the main point is that so you have a selection of tools, because there's not only one method, and how you select tools, that is also important. And so that is not so much black box, I would say. So you have always to combine your ideas how to approach the problem, and backed up with theoretical understanding, and in the best case scenario with experience. For example, if you want to tune hyperparameters, and you don't want to do it, or you can't do this really in the systematic way, or doesn't make any sense in the first place, then that is also sort of a model selection in a way, or how to optimize certain parameters. For this, you can also, for example, use different models, right? Hyperparameter optimization with whatever, with Bayesian methods or something like that, compared to other methods like try and error or brute force searching or grid search or whatever is out there. So and all this stuff is sort of together. So with a black box, I would say, so in recent years, so the point is with data science, you always have to study. So that is the point. So of course you can get your certificate and then your master of applied data science. That is fine, and then you have most likely a job which you really enjoy. And you can also change, as you say. So it's not that you then go for this and then you stay. But the main thing is in data science is because the data will be out, but the data is exponentially growing. That is one. And that requires more methods and better methods. And the number of methods which are published is also sort of, I don't know if it's exponentially growing, but it's like growing a lot. And it's really tough to keep up. So, and what you have to do is to learn all the time. Anyway, maybe some people say that life is about learning all the time, and maybe have a radical departure of your beliefs at some point, and then switch to something else because what you thought is maybe not true, or what you like maybe change. Yeah, those things you have to learn. You have to keep on doing. And I think that is in contrast to many other fields in life. So that is in science, I would say, that is really a key feature of data science. So to keep yourself up to date, because it's not only that architectures are evolving, there are opportunities where to run programs, as you know. And the main thing is sort of what other people call the software also. So the same is the algorithms, and then maybe more systematic ways to compile those algorithms, which then you can refer to as software. And this will be more and more available, let's say, for everyone. And yeah, so everyone will use it. And I think that is challenging. So you have competition, but what can you do? And you can do with this firm analytical understanding, sitting down, which many people don't do or don't have the time to do so. That gives you an edge, and this gives you also maybe probably more fun, and you will be able to figure out things which other people would not be able to figure out. Yeah, so I didn't say about much about the black box. Yeah, what I wanted to say is there's development, so you can actually see which features are of importance for classification by eye. For example, if you have pictures which are two-dimensional objects, can be stored in a matrix, that is fine, and then you can see what features are actually important. So what's the algorithm, what's the deep architecture is looking at or has learned to look at in order to make decisions about the class. So, and there are other techniques, embedding in high dimensional spaces and so on. So it's not that deep learning is as a black box as it was like 2010, when the stuff really started to rise. I would say, so this explainable and interpretable AI, these are interesting fields, and there's a lot of stuff going on also to avoid bias. If you have bias in the database, let's say regarding the skin color or stuff like that, There's ethics in AI. There's a lot of stuff going on. Yeah, I think in the end, we will have sort of an AI which we can understand, but also only to a certain degree, because let's say the AI is general artificial intelligence, like something like you and me, right? So I also will never fully understand you, right? And you will not understand me, and you will also not understand how I make decision, and vice versa. Of course, if it's simple and I give you an explanation, fine. But if it's complicated, and that's the thing, so big data has complicated features, maybe it is really tough to phrase it in language which you or me are able to understand, to explain me, even if it would be sort of in principle understandable, to tell us how an algorithm came up with the solution. So there are like different layers of what can be understood and what means actually interpretable and stuff like that.
And I think on that idea of complexity, and like while being here, it's amazing. Like when you start hearing people that have this experience, that, as you said, is really, really important. You start hearing, okay, so this method that was in 2017, it's way old now, and you have to keep up with the new methods because, as you said, data is growing exponentially. So that is also fascinating because, like, when you study, my background was in economics, so you start studying economic theory from 1700s and 1800s and 1900s, and you see like a slow pace of growth. I think that they're so substantial, but now here in data science, it has as itself, it's growing also exponentially, and also like thinking about the black box and complexity, and also what you said about having more fun when you start sitting down and really understanding what's behind everything. I think also now I'm learning that complexity, it's okay, because sometimes when you're on the field or in a company, it's like keep it simple. Okay, do not go complex, because complexity it's not a thing that we can talk about. As you said, it's really hard to explain once you go, but also it's really hard to now going into a deep dive of tons of data and not thinking that it's a complex world. And going from that, and from your perspective and experience in the field, what should be the role of a data scientist? Because we just heard that we're dealing with learning how to fail or failing less. We're dealing with a lot of complexity that also has, it creates some antibodies inside corporations. And what should be the role of a data scientist also in a company, or even in broader, like in society in general?
Yeah, okay. I mean, I'm not sure if I really can answer this, because I don't want to say, oh, that should be like that, or what. I don't want to define the role of careers. But yeah, let me come back to this little things which I said, that sort of the data science methods attempt to, or should attempt to fail as little as possible with respect to explanation, which is causal. So the point is, going back a little bit to the fundamentals, there's not a single method really which can measure causality. So there is no method for causality. So that is like the thing. It's like there are like methods like range error causality and other stuff which are based on linear models, which came up like 100 years or 50 years ago or something like that. And then there was the advent of the emergence of the data science, machine learning, and in particular deep learning, 2010. So, and then more methods came about, but still we don't really have one. So we are never sure. But so, for example, from the scientific point of view, I would say science in one sentence is like to obtain a result with independent methods. If you only use one method, you may be incorrect. And if you have different methods, let's say you have numerics and analytics, or you have like you figure out a pattern with one method and you figure out the same pattern with another method, or for different databases or stuff like that. So that is a good thing. So now try to come back to the role of a data scientist. So you have to figure out it yourself, because I think you have to find your own niche, and there will be emergence of a lot of niches, right? As you know. So and I think the role is, if you want to be, let's say, a good data scientist. So maybe you can also say, no, I just like want to earn a lot of money, and that is fine with me, and I don't care what I'm doing. I'm not like that, but I'm not subscribing to that, but it's fine. So if you want to do that, that is cool. If you think that makes sense. But I would say I would go for that you can bring something which is unique to your personality and to your education. You can bring some skill set which is also unique. Maybe so you specialize in a certain discipline of data science, let's say, certain method or a certain type of data which you would like to analyze, which you anyway sort of have to do, because typically these job calls are specific for something, let's say, whatever, financial data or marketing data, or and then also specific topics within those categories. So, and yeah, what is really fun, what really bothers you, what is really of interest for you. So I think that makes sense. And then even, let's say, if people would be fine to see a bar chart of some analysis, and there's no analysis of how confident this bar chart is, or what are, let's say, the error bars, or what is actually what you actually did, and what would have come out if you used another method. And also you don't maybe tell what is the theoretical optimal or possible accuracy given this data set, maybe because you create surrogate data and then try with a given method what is actually possible for the accuracy, because there's so many things where you can be on the surface in data science and with your role in the company, and people would also normally not see this. And if you come up with your own standards and say no, so of course I present them my bar chart, but I also know what I'm doing, and there are like different layers, and you find a way to communicate this results, or to communicate your scientific methods. And it should be sort of not engineered a little bit. You should use scientific methods and try to present it in a way that people also value and understand what you're doing. So that would be my my specific recommendation in data science. And in general, I have been asked, like in some conferences, what I suggest to students. I always say, my goal would be, or my advice would be, that you maximize your fun, but not short term, but long term. And that is a sort of blah blah, but because you have to figure out how to do that. But I think it's a good objective, because if you think about it, what does it imply and what does it not imply? I think it sort of makes sense. And you can also apply this to your specific question of data science. If, as I said, if you have fun with doing stuff on the surface and deliver things, I mean, some jobs only require that, then it's also cool. I mean, there's also spare time, right? You can do whatever you want. But ideally, you should grow in your field or in your job, in your role. And it is tough to grow if you just are fine and people around are fine with you that you deliver the minimum, I would say. So, and because you are in data science, you will get a job even if you quit the job. So there's also, you are sort of free. So that keep in mind. Once you go for something else, maybe it's a little bit tougher to get a job, but depending on the circumstances, obviously there's also competition where you are and so on. I'm thinking more or less now about Germany, right? I should not do that. So there are also other countries where if you get a job, you should stay and not quit, more or less, because otherwise it's tough to earn money, because you probably have to wait 3 years, even if you're educated. But yeah, it depends where you are, right? But there are a lot of opportunities as a data scientist, I would say.
Oh, great. That's really, uh, I don't know, like it's coming and going, but as you said, it's a good, that should be the title. Like, what's data science about? Maximizing your fun in the long run.
Yeah.
Because yeah, it does. Like, it's a good career advice in general, like no matter what, where you're coming from. That was actually my other question, but once you start saying like, I have like two more maybe. Uh, there's also like in this role, of course, we can do this bar chart and do not explain what's behind. It's like, okay, this is the door. Behind is a goat or a car. You don't know, and you don't care. But do you have any oh, could you suggest any good data science communicator, like somebody that's out there that you say like, oh, yeah, he or she has a really cool way to really explain the complexity that, I don't know, like it would be fun just to or to tag or just add some of their videos, because I think it's also help people once somebody that has this gift of talking
Yeah.
and unraveling.
Yeah.
Yeah.
So yeah, I mean, in principle, you asked me about sources, right? So let's say on the internet of people. So yeah, I would say it depends. So sometimes, for example, if you want to dig deeper into something, Wikipedia article can be like really good. But sometimes it's the Wikipedia article would be sort of plain wrong or really on the surface or go really biased in one direction. So, and you only know this if you already sort of know the field or knew the answer beforehand. So if you ask me, the same is for YouTube a little bit. So what I can recommend some people. For example, there's some YouTubers which are not like professors or so, but they still dig on a daily basis into recent machine learning techniques, and they also study the stuff or postdocs. And one of those guys is, I think his name is Yannick Kirche, but I'm not sure I should know that. So there are some guys which are really good. So they really have sort of unbiased view on the thing, and you can learn a lot. And then, of course, there are like famous advocates like Andrew Yang or something like this, which co-founded Coursera and stuff like that. You have like so many online courses. So, and then the people who got the Turing Award, the really big shots, as you probably also know. So there are people who are in the field, and some of them are heavily communicating that, and some of them are sort of behind the walls and do their thing. So there's, for example, I can recommend a guy which does a lot of podcasts, Lex Fridman. He is or was at MIT, system professor of computer science. And I think he did like 200 podcasts or so. And partially the topic is not only machine learning and data science, but also other things. And that is very interesting. And he gets all the big shots. He gets all the high calibers. And yeah, just like if you're a fan of popcorn and you want to sit down, it's fine. But then there are also link descriptions. You can dig deeper. And it depends a little bit. So the nice thing about the current internet development is that you have very short movies from people which are very good. Now, of course, you have also people which are not so good and explain you some stuff and it's plain wrong, or it's like not really the thing. But what helps me, for example, also in fields where I just like slightly go over, or so I change a little bit, I want to learn more and different things, is for example Twitter, social media. And then obviously there you can kill your daily life and read everything and connect to everyone. That you should not do. But if you connect to certain people which have some value or recommended by others, then you get a pretty good filter of what is going on. And that can also help you finding sources, what to read, who to watch, and stuff like that. So yeah, I think it makes not so much sense to say, okay, that person, except for this famous guys like, yeah, as I said, Andrew Yang or other people. I mean, there's maybe one guy. So the question is maybe also who's really sticking out of all this fields. There's one Professor Pearl, and he thinks that his framework of causality, it's all about causality, because that is the thing. If we can sort of find an universal framework for measuring causality from data, then we are almost there, I'd say. And he did that, and he is extremely sharp, and his opinions are going also in some direction much farther than other opinions of experts in the field. For example, he thinks that with his causal framework, it is just a question of time using that you can come up with general artificial intelligence, which other experts would say, no, that is not enough. It's other things are blocking that and stuff like that. So Judea Pearl. So also now I remember the name. So as you know from my lecture, I'm very bad in remembering names for whatever reason. But yeah, yeah, that's, I don't know. Does that help you or?
Yeah, no,
something?
It does. There's a lot of, like, for example, the professor, I was saying, I'm starting to get into the field, so it's a professor I haven't heard of, and also, like, I think it's a really good advice just to break the shell of just from a consumer side of just get information, but also to connect people, as you said on Twitter, try to break the bias, or at least try to find sources that already have curated a lot of information. And as you were saying, like this, as we were talking, we're kind of hitting the frontier of data science, as you said. Like we just talking about general artificial intelligence. We also talked at the beginning a little bit more about ethics in data science. And I think that my last question is actually right now, what do you think is the current frontier or the main challenge or the main difficulty that data science has right now as a field?
It's about causal reasoning, or like common sense, like in plain English. So if you, I give this example in my lecture, which you will see in next year, so machine learning 2. So for example, go for a self-driving car, and the main problem is really to understand what pedestrians are doing. So otherwise, there are some problems, but the problems are not so high. Of course, if it's raining, if the sight is very bad, there are other problems, but you can deal with that. The main issue is really to predict what humans do. And the standard example I give is, for example, a couple, which is sort of clear. It's a couple, it's whatever, in love maybe for 1 week and so on, and they maybe push each other a little bit in a playful behavior on the sidewalk, right? Not a big deal. But then there's a car, and it could be that this push would lead that she would fall on the street, and you would have to make a full break because you cannot sort of pull over or switch the lane. So, and that you decide yourself, and you probably don't have really problems. If this couple is not a couple, but it's maybe a criminal who's just like trying to kill someone, then maybe killing someone by pushing this one on the street, then obviously you should have a full break and also take the damage which is caused by that, or swerve to some whatever, I don't know, concrete wall, and then estimate that maybe the damage you will have is okay to accept, compared to that you for sure or likely kill someone by running over them. So those things, that is of course an extreme example, but they're like, so for example, ask Elon Musk. So that is the main point. So he would say, oh, we will solve this like in -2 years. At least he keeps saying this like for many years, as far as I know. But so that is so this autonomous level 5, the highest level, that is a problem. And the problem is not the camera system, it's not the sensors, I think. The problem is really the software, meaning the algorithm. And why the algorithm? Because causal reasoning is problematic. And there are many other examples. And that is the main thing. This what we sort of acquire over our lifetimes is this common sense and this learning from only a very few instances that remain difficult in machine learning and data science. And I think once we go over that, then we are much closer to even bigger achievements. But yeah, we should also not forget that even without this reasoning, we were able to build an algorithm which beats the Go master, for example, which was like inconceivable 15 years ago, absolutely inconceivable. And 50 years ago, it was inconceivable that a computer would beat the chess master. So, and now the ELO, so the ratings of the computers are above 3,000 something. And it's very tough for any human being to go over 3,000. So I think the current chess master with the highest rating has, I don't know, something like 2,800 or so. I can be totally wrong. Maybe it was already in the 3,000. I mixed it up. But you know, it's like at least 500 points or not even 1,000 points away from what a computer can do. And that tells you a lot. And also that is a game, right, with complete information, sort of. You always know the board and all pieces, but also in games is incomplete information like poker, where you have community cards which are not displayed, or I mean, the community cards will be displayed, but you don't know the strategy of the others. And that's not so important, but you don't know really what card he has or she. So, and then some people say, so there was a science paper, I don't know, 5 years ago, where they sort of solved poker for heads up, meaning for 2 persons, which was tough enough because you can bet as much as you want. For limit poker, it's much easier, but still, I'd say it's not really totally solved. In particular, it's definitely not solved for, let's say, 5 people or 4 people or 6 or 9 people on the table. Yeah, my own research goes also like if you're, that's the optimization function where you build the machine learning techniques on. So what you should optimize for, and that may differ on the application also. For example, taking this example of poker, I think that the current theory of game optimal play is actually broken for tournaments because the optimization objective is not correctly phrased. But I still have to publish this and do this work, and it's not on top of my list because there are other more pressing problems than building a computer which builds other computers in poker. So that is not really on my high list, but you know, there's a lot of stuff going on, and then maybe this example tells you also you can really work on the basics, on the fundamentals, and try, this optimization, for example, reinforcement learning, you optimize for this or that. Does it actually make sense? Or for what application is it good for? That is current research, which I'm doing together with students, and other stuff where you say, okay, we have data, okay, what is the best method? So, and between those extremes, just like selecting which 4 or 5 lines of Python code you want to put into your notebook, or what is actually going on, so why what you optimize for at the first place and what you should not optimize for and stuff like that. So in between you have the full range, and yeah, this stuff like this is published and will be published, and yeah, so that is what I said before. So it's also exciting if you can always try to keep up with certain things, but not with all things, obviously. So that is, I mean, it's an exciting topic. And I think what is really important also to the communication skills. So if you present something, you should communicate it. You should know your audience, obviously. You should prepare yourself before you communicate and stuff like that. And that is in particular very relevant for data science, because yeah, so you easily become an expert with nobody can catch up with, and methods change from week to week in a worst case scenario, sort of.
Oh, great! It's really that's a little bit what I had in my plate at the beginning of the conversation. Really, these few questions that just kind of give us I don't know. I think a more professional experience that what you see on the internet, because once you put data science, you just see like learn how to code in Python in 3 months, and yeah, like that might be a part of it, but there's like this whole thing on the side, like all these problems, the complexity, the way you wanted to approach it, and really kind of what you're doing also.
Which is interesting what you're saying, because like a couple of decades ago, there was no programming, right? So, and then there were computer, and then you could say, okay, you can write, you can speak, you can read, and maybe then you can program. And what we do now in data science, yeah, we have to program, right? But is it really programming? It's not so much that the code itself is so complicated that this becomes really an art, right? Of course, if you have a smartphone and you have like limited resources and you want to optimize like this, of course, if it comes to optimization, yes. But if it just like comes to data analysis, I wouldn't say that, oh, my goodness, there's coding is so incredibly important. On the developer side, yes. But let's say for people like you who go like maybe to a company or so, yeah, the programming skills are okay, but it's not so that you say, okay, it's like equal to be able to in literacy, so to write and read and stuff like that. So that changed a little bit with Python, because it's so easy to use and it's on a so high level as a computer language that this goes in a direction, I would say, a little bit away from this difficulties of how to do things, but it also makes our lives easier.